You open your device, ready to get online. Your Wi-Fi icon is glowing, indicating a perfect connection to your local network. But when you type in a standard website name, your browser instantly returns a "site cannot be reached" error. It feels like the internet is completely down. Except the physical infrastructure is actually running perfectly. Your router is functioning, the cables are intact, and the destination website is completely online and waiting for traffic. If you bypass the name entirely and type the exact numerical string into the address bar, the web page loads instantly. This exposes a strict divide in how networks operate. Humans navigate the world using language and memorable names. Computer networks categorically reject those names. Routers and switches only forward traffic based on numerical IP addresses. To understand how the web actually functions, we have to look at the invisible translation layer required to bridge human memory and machine logic, the domain name system, or DNS. Before your browser can display a single image or text block, your device first has to hunt down the exact IP address that matches the domain name you typed. A standard domain name is split into parts: the top-level identifier, like .com or .org, and the main memorable name, like Google or YouTube. Your device sends a query across the network, asking a DNS server, "What are the numbers assigned to this name?" The server replies with the matching IP address, like 142.250.190.78. Armed with these coordinates, your device connects directly to the web host, bypassing DNS entirely. DNS acts strictly as a map. It provides the directions to the destination, but it never hosts, delivers, or transfers the actual website content. Returning to our initial internet outage scenario, we can systematically cross off other networking protocols to isolate why the name failed while the numbers worked. Because your device was assigned an IP address and shows a connection to the router, we know DHCP, the protocol that delivers your local network settings, already did its job. We also know ARP is functioning. ARP maps IP addresses to physical hardware on your local network, and since your device can still talk to your gateway to reach the outside world by number, that local link is healthy. Yet a strange symptom often appears during these internet outages. A website you visited 5 minutes ago might still load perfectly, while every brand new search fails completely. This happens because of a mechanism called the DNS cache. Your device actively stores recently translated IP addresses in a temporary local memory, saving it from having to query the central directory server for sites you just visited. When a localized internet outage blocks new websites but allows cached ones to load, it definitively proves that the physical network is intact. The translation system is what failed. This translation process extends far beyond typing URLs into a web browser. DNS operates in the background when your smart TV loads a streaming service, when your mobile phone refreshes its email inbox, and when a video game console connects to a matchmaking center. If DNS functionality were permanently stripped from the internet, every physical cable, fiber optic line, and router would continue to operate flawlessly, but the network would become virtually unusable. Society would be forced to memorize shifting, unstable catalogs of complex number strings just to check the daily weather or send a text message. The physical internet is a cold machine built entirely on numerical logic. DNS is the system that takes that numerical architecture and makes it readable for us, allowing the entire digital world to be navigated through human language.